Okay, so this is chapter 5, factors, so equation of a plane. So basically, to form the equation of the plane, we can use the formula r dot n equal to a dot n. Okay, so what is r? R is simply xi, y, j, and zk. So n is a vector such that it should be perpendicular to the plane. And then what is a? A is the fixed point on our plane. And then n again, this is a vector such that it should be perpendicular to our plane. So if this is our plane, then this is gonna be our normal. So this is a vector such that it should be perpendicular to our plane. And then we have one fixed point over there called the A. Okay, so we can actually represent them into two forms. So we can have a vector form as well as the Cartesian form. Okay, so now let us see how do we obtain the equation of a plane. Okay, so this is the first case. They give us 3 points and then we have to obtain the equation of the plane. So for example, if let's say you are given point A, point B, and point C, and then you were told to find out the equation of the plane consisting of all these 3 points. If you have 3 points, we need to find two vectors first. So do make sure you calculate AB and AC. So that is the first step. Do calculate AB and AC. After that, to calculate a normal, you simply do AB cross with AC, or you can do AC cross with AB. And then we're going to substitute the n into here. So r dot n is equal to a dot n. So let us see one example. So a plane containing the point A, B, and C. Determine the Cartesian equation of the plane. So like I told you before, the first step we have to calculate AB and AC. So let me calculate AB first. So AB using the formula is supposed to be OB minus with OA. So OB, B is 2, 1, negative 1. A is 1, 0, 3. So you minus them. 2 minus 1 is 1. 1 minus 0 is 1. Negative 1, negative 3. So this is negative 4. So this is AB. And then of course we have to calculate AC. So AC is actually OC minus with OA. So OC, C is negative 1, 2, and 1. OA is 1, 0, and 3. So we're going to deduct them. It will become negative 2, 2, negative 2. Okay, so now I already have AB and AC. So now this is our second step where we have to calculate the normal vector. So normal is AB cross with AC. So we're going to do the I, J, and K. So I, J, K. So AB is 1, 1, negative 4. And then we have negative 2, 2, negative 2. Okay, so we're going to delete the first row and the first column. So first row, first column, we're going to get 1, negative 4. 2, negative 2, I. Minus, deleting first row, second column. 1, negative 2. Negative 4, negative 2, so this is for J, plus, deleting first row, third column, so we're going to get 1, 1, negative 2, 2, and this is for K. And then of course, to calculate the determinant, we simply need to do AD minus BC. So negative 2 plus with 8, so negative 2 plus 8, so this is 6I, minus, so we got negative 2, negative 8, so it should be negative 10, so this is positive 10 J, and then 2 plus 2, so this is plus 4K. So second step done. I already know what is the value for the n. Now the equation of the plane, we have to use r dot n equal to a dot n. So r is simply x, y, and z, dotted with the n, so 6, 10, and 4, equal to, so I have 3 fixed points. I can choose any one of them, but since I'm using A, B, and AC, let us choose the A. So this one is 1, 0, 3, dotted with 6, 10, and 4. And then of course you have to do the dot product, so x times 6, 6x, plus with 10y, plus with 4z, equal to, so this one gonna be 6 plus with 12, which is equal to 18. So now let us divide everything by 2. Therefore, we're gonna get 3x plus 5y plus 2z, and this is equal to 9. So that is the equation of the plane. Okay, so let us proceed to the second one. Okay, so if let's say we are given 1 point and a parallel plane. Okay, so this is the plane that we want to find. So this is pi. And then we have a parallel plane, so we have something that is parallel over here. So what we can say is that if this is what you are given, you're gonna have one n from here. So I'm gonna call them as n1 because this is pi 1. So since these two are parallel, that means the n should be parallel to the n here. So we can say that n must be equal to n1. We can straight away use the formula r dot n equal to a dot n. So do make sure to take out what is the value for n over here, and then we can use the formula straight away. Find an equation of the plane passing through the point Q, 1, negative 2, and 3, and it should be parallel to the plane 3x plus 6y minus 2z equal to 4. So firstly, let us take out what is the n first. So the n, you simply take the coefficient of the x, the y, and the z. So the coefficient is 3, 6, negative 2. So that is our n. Meanwhile, for the fixed point, I have the point over there. So 1, negative 2, and 3. So now let us substitute into the formula r dot n equal to a dot n. So r is x, y, z, dotted with the n, 3, 6, negative 2, equal to the fixed point 1, negative 2, 3, dotted with 3, 6, negative 2. So we're gonna do the dot product. So 3x plus 6y minus 2z equal to, so 3 minus with 12 minus with 6. So this is negative 15. So we're gonna get 3x plus 6y minus 2z equal to negative 15. Okay, so next, 1 point and 1 perpendicular line or a vector. So this is the plane that we want to find, and then we have a fixed point over there, and then 1 perpendicular line or perpendicular vector. Okay, so basically, if let's say this is your line, you're gonna have something called a v. But if you are using the definition of the normal is actually a vector such that it should be perpendicular to our plane. Therefore, we can say that n must be equal to the v. And we can straight away use the v over here. So r dot n must be equal to a dot n. So let us see one example on how to use this one. So find an equation for the plane passing through the point Q and perpendicular to the line over here. Okay, so from here, I need to take out the v because the v is actually the n. Okay, so now let us take out the v. So how do we find the v? So if you can see this is x, this is positive y, this is positive z. Once the coefficient of the x, y, and z is 1, we can simply take the number below this. So this is actually your v. So v is 3, negative 2, and negative 1. And since we know that v is perpendicular to our plane, so this is v, then we can say that v is actually equal to n. So this is actually our normal vector. And since this point must pass through the plane, so this can be considered as a fixed point. So you're going to substitute into the formula r dot n equal to a dot n. So r is x, y, z, dotted with n. So n is 3, negative 2, negative 1 equal to a. So I got 1, negative 1, and 2 dotted with the n, 3, negative 2, negative 1. So do the dot product for this. So you're going to get 3x minus 2y minus z equal to, so 1 times 3, 3, negative 1 times negative 2, so plus 2 and then minus 2. Therefore, we're going to get 3x minus 2y minus z, and this is exactly equal to 3. So done with this. So let us see the last one. Okay, so what happened here is that on your plane, it will contain of one fixed point, so that is A, and then you should contain a line as well, so we should have a line over there. So what happened is that from your line, you should take out what is the value of your V. So from the equation R equal to A plus dV, we should know two things from the line: where is the fixed point and what is the parallel vector. So from the line over here, do make sure you know what is A and then what is V. But since we already call this one as V, let me call the fixed point as P so that we don't get confused. So we should take out what is the value of V, and then since you couldn't see anything that is perpendicular to your plane, we should find them. Therefore, we have to do the cross product. Make sure you have two vectors first. So one of the vector is the V. So in order to find another vector, since we have 2 points here, A and P, we should find the vector AP so that we can have two vectors on top of the plane. If you have two vectors on top of your plane, you can actually cross them, and then we can easily get the normal vector. So that is actually our aim. Okay, so I already have the V, so the parallel vector comes from the line, and then AP, so this A comes from the line, and then P is the fixed point from your plane. So we're going to find the direction vector from the fixed point on line to the fixed point on plane. So we can get two vector now on our plane. Once you have those two vector, do make sure to do the cross product for them, because we want to find our normal vector, a vector that is perpendicular to our plane. So once you have two vectors, you can actually cross them to get the normal, and then we're going to substitute into the formula r dot n equal to a dot n. So let us see one example for this one. Okay, so find an equation for the plane containing the point P, negative 4 to negative 3, and the straight line L, x plus 2 over 4 equal to y over negative 3 equal to z plus 1 over 5. So firstly, from the equation of the line, let us take out what is the A and the V. So A is the fixed point. So what we can do is that since this is x, y and z, we can simply refer to the number behind them, and we can actually times them with negative 1. So this is negative 2, 0, negative 1. So those are A, or you can call them OA. And then another one is called the V. So V is the number below here, so you can simply take them straight away. So this is 4, negative 3 and 5. So those are V. So once you know the V, we have to calculate AP as well. So this is OP minus with OA. So P is the point on the plane. So I'm going to see the number here, negative 4 to negative 3 minus with OA. So A is negative 2, 0, negative 1. So deduct them together. So negative 4 plus with 2. So this is negative 2. 2 minus 0, 2. Negative 3 plus 1. So that is negative 2. So once you have AP, then it's time for us to calculate the normal vector. So normal vector is AP cross with V. So do the I, J and K. So AP negative 2, 2, negative 2. V is 4, negative 3 and 5. And then we simply find the determinant for this one. So deleting first row and first column. So 2, negative 2, negative 3 and 5. I minus delete first row, second column, negative 2, negative 2, 4 and 5. J plus first row, third column, so it's going to be negative 2, 2, 4, negative 3. Okay. And then we simply do AD minus BC. So 2 times 5, 10. 10 minus with 6, so this one gonna be 4i. Minus, so we got negative 10. Plus with 8, so this is negative 2j. Plus, so we got 6 minus 8, so this one gonna be negative 2. Okay, so what do we have is 4i plus with 2j and then minus with 2k. Okay, so I do know the value of n, then we can simply substitute into the formula. R dot n is equal to A dot n. So R is x, y, z. N is 4 to negative 2. And then A is the fixed point on plane, so we are going to use this number. So negative 4 to negative 3 dotted with 4 to negative 2. So what are we going to get is 4x plus 2y plus 2z equal to negative 4 times 4, negative 16, plus with 4, and then plus with 6. So this is negative 6. So we have 4x plus 2y plus 2z equal to negative 6, and of course you can easily simplify them. So it's gonna be 2x plus y plus z equal to negative 3. Okay, so what is the most important thing in order to obtain the equation of the plane is that you will need to find what is the fixed point on your plane called the A, and then a vector that is perpendicular to your plane. If you couldn't find anything that is perpendicular to your plane, do look out for these three things. Can you find any line such that it should be perpendicular to your plane? Or can you find any plane that is parallel to your plane? Or can you find any two vectors on your plane? If you can find any two vectors on your plane, then you can do the cross product in order to obtain your normal vectors. So see you in the next part.